Okay. I'm pretty sure I'm live. I don't know if anyone saw that, but I was live and I was on my phone, but it's hot outside and my phone overheated, so I'm gonna try this again on my computer. Hopefully everything goes well. But I'm just gonna start over. So today I'm gonna be talking about how refraction works. And pretty much, so first I'm going to be talking about how refraction works, then I'm going to be showing a demo on how we can use refraction to actually turn sunlight into the color spectrum. And yeah, and then I'm going to tell you all about how it works. So first let's start with refraction. Okay, oops, sorry, my marker's stuck. Okay, how refraction works. Okay. So, you may have already seen refraction in real life if you've ever had a cup of water and then you put a straw in it, right? And you would expect the straw to look like it goes straight down, right? Because that's where the straw actually is located. But if you've ever done this before, you know that this is not actually what it looks like, right? Instead, it looks something more like this or something like that, where it almost looks like someone cut the straw and moved it over and it's not actually the same straw, but we know it is the same straw. So how does that happen? Well, it's because air, so up here the straw's in air and down here the straw's in water, and they have a difference in something that's called the refractive index. So the refractive index is pretty much the ratio of how light travels in air to how light travels in that medium. So air has a refractive index of 1, because that's what we're comparing it to, and water has a refractive index of about 1.3. And obviously 1.3 is higher than 1, and every medium has a different refractive index. So oil has a higher refractive index than water, and you may have seen, if you've ever seen like a picture or video of the oil spills that happened a while back, the oil almost looked like it had different colors in it. That's because oil has a higher refractive index than water, and the light refracts differently. And same thing with diamonds. So if you ever look at like a diamond ring, you may notice there's lots of different, it looks shiny, it looks like there's different colors in there. That's because diamond has an even higher refractive index. Okay, so refractive index is how the light travels through that medium, okay? And let me show you how this kind of plays into how light reacts to refractive index. So again, let's say this is air and this is water. Okay. And let's say you have light that just comes in, something like that. It's just a beam of light, and it goes from air, and it's just as it hits the water, it's gonna change direction and look something maybe like this. And I know I didn't do like a huge difference, but, or I guess I can just redo it because those look pretty similar. But okay, let's say it goes something like this. It might come off something like this. So as you can see, this is not a straight line. Going in the air, it had this angle, and then once it hits water, it has this angle, right? And those are not the same angle. And pretty much, again, now we're getting into math and, you know, more complicated stuff. But how this, oh, sorry. Let me finish writing this. Okay, my handwriting's horrible, but you get the picture. this is Snell's law. So it relates, this is the refractive index of the first medium. This is the angle that it's hitting it. And this is the refractive index of the second medium and the angle that it's hitting it. So you don't actually have to know that, but essentially just know that the angle that it, the angles that it comes in at and it leaves at is related to the refractive index. Okay, so now the fun part. I'm going to show you how we can use this to make a rainbow. Okay. Let me come over here. So, I don't know if you can, no. I can't really see because it's bright outside. Okay, there. So I have a bucket and a mirror, kind of tilted off at an angle. Yeah, so there's water and there's a mirror, and that's essentially all it is. There's the mirror's in at an angle, and then when we, I don't know if you can, okay, yeah. So, oops, let me come a little closer. Okay. So here we have like a rainbow. So it goes like red, orange, yellow, and then there's a big white space, and then it kind of finishes off green, blue, purple, and then we almost see like a second rainbow. Yeah, okay. So what is happening is, I don't know if you guys can see this. Sorry, it's really bright out. But essentially, the light is coming in as white light, and it is going through the water, which has a different refractive index than the air. And the waves are kind of splitting up, and then they reflect off the mirror, and they come back out at different angles. And yeah, so I'm going to show you a little bit more about how this works. Sorry if that was a bad visual. I couldn't really see what you guys were seeing, but I hope you guys saw that pretty well. Okay. So what happened was we had this bucket, and we had water, and we had a mirror at a tilt. I hope you guys could see that much. And then we have the sun over here, right? And from the sun, we have white light. So white light is actually a combination of all the other colors. So in white light, we have red, orange, yellow, green, blue, indigo, purple, and they're all on top of each other. And when they're all on top of each other, it appears white, not colored. So, okay. So the light comes in all 2, 3, 4, 5, 6, all right, very close to each other, all at one angle, right? And then it hits water. And because of what we know about refractive indices, we know that it's going to have a different angle than it did before when it was in air. And also, another thing about refractive indices is that different wavelengths perceive the medium differently. So red light might come in at a different angle than ultraviolet light. So this, let's say it's red, it might come here. This one might come at this angle, this angle, this angle. Okay, so they're all at different angles, and that's because I don't have enough markers to show it, but pretend each of these lines are a different color, right? So they're each a different color, and they're each a different wavelength, and then so when they come into water, they each come off at a different angle, right? And then, once it hits the mirror, it reflects off the mirror, back up, and then it's going from water to air again, and it's going to refract again. So let's say it's like this. Oops. Right, okay. So over here, all of the different wavelengths were really close together and all at the same angle. But now, once it went through water and once it reflected off the mirror, now they're all at different angles and they're all kind of spread out. So essentially what I did in that demo was I just put a piece of paper right here, and you could see all the different colors on the paper. And I know in the demo it almost looked like there were like gaps and multiple different rainbows, and that's probably just because of you know, here in this example it's all just one source, but out here it's like a larger sun. The sun's coming like all of these different ways, and there's a lot more different sources and a lot more light and reflection going on. But yeah, essentially if we just look at one ray, this is what's happening. So it came in as white light and it splits off and we can see the colors. And yeah. And just for fun, because I'm not sure how well that demo showed, so I'm going to try to do it one more time. Okay. 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 So you can see the mirror is tilted in the bucket of water. Like we said, we know that, can I see it? Okay. We know that the light is coming in at one angle and it's reflecting off that mirror. And then once that happens, we get this. Yeah. So there's a rainbow. Woo! Okay. So I hope you all enjoyed that quick little demo on refraction and how it can work to turn the sunlight into a rainbow. And I don't know. Yeah, no. Okay. Thank you all for watching, and this video will be on YouTube later, so you can share with your friends or rewatch if you missed something. And thank you.